Hi everybody, welcome to 2.4 where we're going to look at multiplication with integers. So by the end of this section we'll be able to multiply any numbers that are integers, including negative numbers, including multiplying positive and negative numbers together. And we'll be able to simplify exponential expressions with positive and negative bases and evaluate algebraic expressions. And so basically what we'll be doing is a lot of what we did in chapter 1, but now with negative numbers included. So let's have a look. The first thing we're going to do is we're going to remember that multiplication can be thought of as repeated addition. That's where it comes from. And so if we have something like 3 times 5, we know that that is a couple of ways to write this. The most common way is 5 plus 5 plus 5, or 5 added together 3 times. And 5 plus 5 is 10, plus another 5 is 15. And so that's why we know that 3 times 5 is 15. Now, with negative numbers, we can do the same thing. We can say 3 times negative 5. Well, 3 times negative 5, a couple of ways I can think about it. I can say, well, 3 days in a row, I borrow $5. How much do I owe at the end of that? Granted, I already know that I owe money because I'm borrowing money, right? So I know I'm going to end up with a symbol that shows debt or borrowing, the negative. But I want to be able to think about this in terms of repeated addition. Well, I can. I can think of this as negative 5 plus negative 5 plus negative 5. And negative 5 plus another negative 5, that's negative 10, plus another negative 5, that's negative 15. So 3 times 5 is 15. 3 times negative 5 is negative 15. Now, we can also do this if the negative is attached to the first number, the first factor. The best way to think about this probably is to think about 5 negative 3's added together. So rather than to think of negative 3 5's added together, that's a little bit harder to kind of get our brains around. So let's think about it like this. Let's say I rewrite it because of the commutative property of multiplication. I know I can rewrite multiplication if it's one number times another as the reverse order, and it's still the same result. And then I can think of this as, 5 negative 3's all added up. And so I have 5 negative 3's added up, repeated addition, and that's what multiplication is. And that's why we learned to add the opposite in the last section, because it'll help us to sort of make the connection between multiplication with positive numbers and multiplication with negative numbers, because the multiplication part actually remains the same. We just have to decide what the sign is going to be. And so you can see here, negative 3 and another negative 3 is going to be negative 6. All right. And now negative 6 and another negative 3 is negative 9. Negative 9 and negative 3 is negative 12. And negative 12 and negative 3 is negative 15. So you can see here that when we multiply two numbers, 3 and 5, if they're both positive, as in the first example, then the result is positive. If one of them is negative, in the second and third example, then the result is also negative. So hopefully that makes sense. And so now Let's go ahead and apply what we know about multiplication so that we can generalize these rules. So let's have a look at these A, B, C, and D here. So the first is 2 times 4. So we know that 2 times 4 is 8. And since they're both positive numbers, we don't really end up thinking about a sign. But the the way to think about this is that since the signs are the same, since they're both positive, you're going to end up with a positive result. Now let's look at B. What happens when I'm multiplying and both of my factors are negative? Well, think about this. Think about owing $4 and then taking away that debt 2 days in a row. Well, if you take away $4 in debt, if you take away $4 in debt, you take it away 2 days in a row, that $4 in debt, then that has given you $8. Right? You've received $8 if you relieve $4 in debt 2 days in a row. And that's what this expression can be read to understand. So when the signs are the same signs, positive result. Right? So 2 positives make a positive, and 2 negatives also make a positive in multiplication. Now, what happens when we have one sign of each? One's positive and one's negative. What happens there in multiplication? Let's have a look. So 2 times negative 4. So I borrow $4 2 days in a row. So now I owe $8. And how about this? I can think of this as borrowing $2 4 days in a row. Well, if I borrow $2 every day for 4 days, then I'll owe $8 at the end of that. So when I have one of each sign, one positive, one negative, right? One plus, one negative, or one negative, one plus, then the result in multiplication is a negative answer. If I have 2 positives or 2 negatives in multiplication, then the result is a positive answer. And so hopefully this table here summarizes what we know about multiplication with integers, which is that we multiply the absolute values of the numbers. 2 and the 4 is going to get 8 every time. And the only thing we have to decide is whether we have 2 of the same sign, in which case it's positive, or if we have different signs, in which case it's negative. Now let's use what we know to simplify an expression here. Now we're following the order of operations, so we're looking for anything to do inside parentheses. There's nothing inside parentheses to do. We're looking for any exponents. We don't have any, so we're on to multiplication and division, and we're going to go from left to right. So even though multiplication is subject to the commutative property, which means we can actually change the order of multiplication and it won't change the result, we are going to do the multiplication in the order we get it. And so here, the first thing I'll do is multiply negative 3 and 2. Negative 3 times 2 is, they're opposite signs, they're different signs, so I'm going to end up with a negative. 3 times 2 is 6. Now I bring everything else down. Now the next thing I'll do is multiply negative 6 times negative 5. In multiplication, when the signs are the same, the result is positive, so I actually don't even need a sign, right? I could write one, but I don't really need one. 6 times 5 is 30, and I know it's a positive 30 because I don't see a sign. So one thing you can do is if you look at the original problem and you see, oh, there is an even number of negative signs. There's 2. That means they're going to pair up and become a positive. So if I had had an odd number of minus signs, like say all 3 numbers were odd, or excuse me, all 3 numbers were negative, then when the first 2 multiply together, you would end up with a positive. But then when you multiply the third negative, you'd have an odd number of negatives, so you'd end up with a negative, and your result would be negative. So let's do another one. This one, we're going to follow the order of operations, but instead of being able to just get right down to multiplication, we have to follow the order of operations and do anything inside the parentheses first. So this has got to get resolved first. So everything else is going to come down. And the parentheses aren't going anywhere because they're showing me this multiplication here. So they can't go away until that's done. Negative 6 plus 2. So now we have to go back to our knowledge of exponents from 2.2 and say negative 6 plus 2. So if I owe $6 and then I make a $2 deposit, I'd only owe $4. Okay, that makes sense. Now, I'd love to just get right into the addition, but I have to follow the order of operations and I have to multiply and divide before I do any addition or subtraction. So I'm going to take care of this multiplication right here. So the negative 4 is going to come down. Now, the best way to think about this when multiplying is to take the sign in front of the number and to think about a positive 5 times a negative 4. Now, what's a positive 5 times a negative 4? The signs are different in multiplication. That results in a difference sign, which is the subtraction sign, minus. 5 times 4 is 20. So it's really important that we follow the order here and that we pay attention to the signs that precede the number, right? The sign that comes before the number is the one that is attached to that number and has to go with it. Now, I could think of this as negative 4 minus 20 more. That's a little confusing, so I'll turn this into addition of the opposite. So instead of subtracting a 20, I'll add a negative 20. And now I can see, oh, I owe $4, and then I borrow another 20, so now I owe $24. Now, let's just take a quick look at this problem and see what would have happened if I had not paid attention to the signs. Would I have gotten in trouble? Let's see if there's a way to do this. Instead of thinking about this as a plus 5 times a negative 4, I'm just going to worry about bringing down my minus 4 plus and then something in parentheses, right? Probably. Now, 5, if I'm not thinking about this plus here, because it already came down, then 5 times negative 4 is negative 20. Oh, so that is the same thing. It just looks a little different. Now, sometimes this version is easier to work with, and sometimes the other version is easier to work with. And it kind of depends on the problem, and it depends on your preferences. I personally don't mind looking at this one, this top one here. But a lot of folks prefer to think about this bottom version. They are the same. And so all that matters is that you understand what it means and that you do it the way it makes sense to you, that you can repeat every time. So negative 4 plus negative 20, that's negative 24. So you can see I can get to the same result as long as I follow the rules and I don't leave anything out, then I'll be okay. All right, so this is what we've done so far with multiplication. When the signs are the same, you get a positive result. When the signs are different, you get a negative result. So if the signs are the same, they use the symbol for the sum. And if the signs are different, they use the sign for difference, the negative. So hopefully that makes sense. And let's look here. So this is kind of the summary of what we've done, multiplication of any two numbers, any two integers, right? So we're not talking about fractions, decimals, percents, anything like that yet. We're just talking about integers, the whole numbers, and their negative counterparts. So I'm looking here at number 1. The answer is positive So the answer of multiplication, the result of multiplication is positive if the original numbers have the same sign, right? So if there are two positives or two negatives in multiplication, when they multiply, they'll turn positive. Part two, the answer is negative if the original two numbers have different signs. So if one's negative and one's positive, or one's positive and one's negative, then the result will be a negative. So those are that's a summary of the two properties that we hopefully now understand. Okay, so now we can apply what we know about negative numbers in multiplication, and we can understand how exponents work. So let's look at A. Negative 6 to the second power, or negative 6 squared. We know that the exponent, the 2 up here, right, means how many times you're going to write the base in multiplication. So the base is negative 6, and how many negative 6's do I have in multiplication together? 1, 2. Negative 6 times negative 6, well, a negative times a negative is a positive, right? The signs are the same in multiplication. That's a positive. 6 times 6, 36. So when you square a negative number, you end up with 2 copies of the minus sign, and so they're going to pair up, cancel out, and you're going to end up with a positive result. Now let's compare that to this. Negative 6 squared. As confusing as this might be, it's really important to recognize that in example A, the negative sign was included in the base because the parentheses were showing us that negative 6 was the base. In B, the negative sign actually comes in the order of operations, it comes at the level of subtraction. And so because it's at the level of subtraction, it is not as powerful as multiplication and exponents. And so it doesn't get to be resolved initially. So first what we do is we square the base, which is 6. And so what I'm doing is I have this minus sign that's stuck out in front of my number, and it's going to remain there until I've resolved the exponent, and then I can think about what to do from there. And so what I'm squaring is 6, so it's really 6, and actually let's do it in parentheses the way they did it here. It's really 6 times 6. Now, I can't do anything with this minus until I've resolved the multiplication, because multiplication comes before subtraction. So 6 times 6 is 36. And because there was only one negative sign sitting out front the whole time, waiting for me to resolve the exponent, it's going to remain there and continue to make the 36 negative in this example. So there's a huge difference between when the negative is included and when the negative is not included in the base. Now, when does this make a difference? Interestingly, this makes a difference when exponents are even. In other words, a 2 or a 4 or a 6, because then there will always be an even number of negatives pairing up together, right? And so then it'll always turn positive. And if the negative's sitting out in front, then the result will always remain negative. Let's look at C and D and see how they're different when we have an odd exponent. So negative 4 to the third power, or negative 4 cubed. And what this means is 3 factors, 3 multipliers of negative 4, because the negative is included in parentheses, clearly showing it's part of the base. So we write this as negative 4 times negative 4 times negative 4. Now a negative times a negative cancel. Well, maybe let's think about it like this. The opposite of a negative is a positive. 4 times 4 is 16. Now I don't really need the plus, as long as I know that it's still multiplication. A positive 16 times a negative 4. A positive times a negative is a negative in multiplication, different signs. 16 times 4 is going to be 64. So what happened here? When there was an odd number of minus signs, right? Because there was 1, 2, 3 negative signs. Two of them would pair up and make a positive, and there'd be one left over that would turn the answer negative, that would keep the whole answer negative. Now let's look at part D, negative 4 cubed. Now here, the negative is at the level of subtraction. It is not included in the base. The base applies to only the 4 unless the parentheses show us otherwise. So this is negative 4 times 4 times 4. And so the negative is going to kind of hang out in front, and then I'm going to have to resolve 4 times 4 is 16, still times 4. A negative 16 times a positive 4 is a negative. 16 times 4 is 64. So when my exponent is even, like a 2 or a 4, then it matters, it really will impact the answer, whether the negative is included in parentheses as part of the base or not. And when the exponent is odd, like a 3 or a 5, right, a cube, for instance, in this example, then there will be 3 of whatever sign I have, in this case a minus sign. And so 2 of them will pair up and make a positive. 1 will always be left over, just like the one that's left over when it's not included in the base. So this is really important. For sure, a problem like this will be on a test, so it's definitely one worth practicing so that you really understand when the exponent applies to the minus and when it doesn't. And it's all about what's included in the base, and that's why the parentheses are so helpful here. Okay, the last thing we want to do in this section is evaluate algebraic expressions. And so you can see here this table, we've got a whole bunch of different algebraic expressions, right, where we use a variable term like an x or an a or a p or a y in these cases, right, all different variable terms. We're just using a letter to substitute for a variable value, right? And it can either be a value that we do know, as in this case here where they've told us what the value of the variable is, or we may not know it. It may simply be an expression where, in this case, 5x plus 2, that's as good as it gets, right? 5x plus 2 is as simple as it can be until we know what x is, right? And then once we know what x is, we can substitute the value that x is for the variable in the original expression, and we can evaluate it. We can get a single answer. We can simplify even further. And so let's look at the example down here below. Evaluate negative 2x plus 3. And we want to do that for x equals 4. So in this example, they're saying, suppose x is 4, what would the expression negative 2x plus 3 simplify to? And so what we want to do is take this value and plug it in for our variable term. So negative 2, now negative 2x, that's multiplication, but whenever I'm substituting, remember, I use parentheses to protect the number I'm substituting because I don't know what kind of a situation I'm putting it into. So it's got its guard up until it knows, well, are there exponents? Is there multiplication? Are there multiple negative signs that I need to resolve? So parentheses are essential. Now, once I've substituted in for my variable, the number I think my variable is worth, I can go ahead and simplify. And so following the order of operations, I would do the multiplication before I would do the addition. So I've got negative 2 times 4, so that's negative 8. Now I only have this addition left to do, negative 8 plus 3. So if I owe $8 and then make a $3 deposit, now I only owe $5. So when x is 4, negative 2x plus 3 is negative 5. And that's what this shows. I can take a variable expression, an algebraic expression, and I can substitute a value for my variable, and I can simplify my expression and see what I get. So these are the key concepts. So let's, you can take a second, pause this, answer them yourself, and then we can look at them together. So for A, write the multiplication problem 3 times negative 5 as an addition problem. So write this as addition. So what I would do is I would say, well, it's 3 times negative 5, so I have negative 5 added up. Oops. Negative 5 added up 1, 2, 3 times. And of course, they didn't necessarily want us to simplify this further, but we can. 3 times negative 5 is negative 15. All right, B. How may we apply the distributive property to a multiplication problem? Well, here's one way to think about it. What if we had something like this? 3 times 2 plus 4. I could say that's 3 times 6, and then say that's 18. But I could also choose to distribute the 3 and say, well, that's 3 times 2 plus 3 times 4. Let's see if that's still true. 3 times 2 is 6. 3 times 4 is 12. 6 and 12 is 18, so it checks out. So the distributive property can be used with a multiplication problem if I have things adding or subtracting inside parentheses and a multiplier out front. I can choose to simplify inside parentheses first, or I can preserve the meaning and I can distribute the multiplier to the parts inside. And as long as I triple both parts or I double both parts, then I'll maintain the same relationship. All right, C. If two numbers have the same sign, then their product will have what sign? So if two numbers have the same sign, their product, the result of multiplication of two numbers with the same sign, is a same signs equals, and then D. If two numbers have different signs, different signs. So if they have the same sign, the result of multiplication is positive. If they have different signs, the result of multiplication is negative. And that will always be the case. So you won't learn some other property about multiplication later on. It's always been true. It's just that we were working with positive numbers in chapter 1. Now we're working with negative numbers in chapter 2 and for the rest of our time. And so we want to know, okay, if I'm multiplying, if they've got the same sign, it's a positive answer. If they have different signs, it's a negative answer. And remember, this is true for multiplication. And as we'll see in the next section, it will be true for division as well. So join me then